All right, well, hi everyone. It's so great to be here. It's been, I think, exactly 14 years since I was here. You're in a beautiful new building. I'm sure many of you are new to campus, and it's just wonderful to be back. If you're wondering why I'm wearing AirPods, there's this really great podcast that I'm listening to at the same time as talking. No, this is for audio for the Zoom. So I realized a few months ago that I've worked in accessible technologies for people with disabilities for about 20 years. And I thought it would be great, given that it's been 20 years, to revisit some of the grand challenges that we worked on 20 years ago and to some degree are still working on today in accessibility. And I think there's a couple of reasons for that. I think one is that it's always really fun and useful to think about the very real progress that we've made in some of the hardest challenges that we saw back then. But also I think it's a good reflection on, a good time to reflect on the problems that still remain, especially as so many things have changed. Most recently, AI has really kind of taken off even more so than before. But to some degree, what has happened is some of these grand challenges have just kind of taken on more depth. And so I think I wanted to revisit 7 of these today. The other thing is I should just call out in the very beginning, I do not think that these are the only challenges in accessibility or even necessarily the hardest or most important, but they are 7 that I've kind of chosen because I think they're hard. They've remained hard over a number of years, and also they're things that obviously I've worked on, and so it gives me a chance to talk about my own work. All right. One thing that I had 8, I don't know what I put on the title for this, I had 8 grand challenges. The 8th grand challenge is actually, that I wanted to revisit, was how do we motivate accessibility? This might sound kind of obvious, but it's really kind of taken on a number of different forms over the years, and the way that we think about, like, how do you think about motivating accessibility? You heard Jan say one thing that I have come to appreciate is, looking at accessibility is really this window into the future because of how people with disabilities are often the earliest adopters of technology, including AI. But I wanted to revisit that because I think it actually helps set a grounding, especially for a general audience. So one is, there's a huge diversity of people, and the best way that I have found to represent this is actually a slide that's created by the Chief Accessibility Officer at Microsoft, Jenny LaFleur. And what I think is really great about this particular way of motivating accessibility and the diversity of different people and abilities that come to accessibility is that it's kind of grounded in real people that you might know, so these celebrities. So just to quickly go through, within visual, we have our representative Ray Charles, but even within visual disability, you start to see there's all of these different kinds of visual disabilities. So you might think about blindness, but there's also low vision. There's a whole spectrum there. Think about color blindness, different kinds of color blindness. Go to hearing, we have Marley Matlin. Hearing loss, people who are deaf who prefer sign language, people who are deaf who maybe don't know sign language, lots of variation. Cognitive, with Temple Grandin there, huge number of different kinds of disabilities are categorized under cognitive. We have dyslexia, people who experience seizures, learning disabilities, autism, obviously a large spectrum. Speech disabilities, so James Earl Jones, kind of famous for his speech, but also who had experienced a speech impairment as he aged. There's everything from accents and speech impediments to people who are unable to speak. We have mobility, Josh Sundquist. We have arthritis, quadriplegia, spinal cord injury, neural with Catherine Zeta-Jones, bipolar, anxiety, PTSD, depression. And then because a lot of times, but not always, disability is a consequence of some underlying disease, a lot of times those diseases actually cause the disability to be experienced across these different categories. So we have Michael J. Fox, the representative here of Parkinson's disease, and this affects everything from cognition, speech, to mobility. ALS with Stephen Hawking affects mobility and speech. And so the reason to run through all of this is hopefully with those kind of concrete examples, you start to see, wow, this is expansive. There are just so many different kinds of disabilities, and consequently, there's so many different ways that people need to be able to interact with computers to be able to support the abilities that they have. And so I've also noticed that despite all of this, a lot of times, accessibility is kind of seen as narrow, and so people try to expand it in various ways. They think about there's 15% of the US population that has a disability. They think about how, you either have currently or will have a disability if you're lucky enough to live long enough. And then people talk about situational impairments. So, if you walk down the street and you see someone staring at their phone, they have a situational impairment where they might bump into people. But despite that, accessibility is kind of seen as narrow, and it's really hard to convince people otherwise. But really, this narrow way of thinking about how we interact with computer, I argue, is not accessibility, actually. So if you're thinking about the specific, say, high acuity, high motor dexterity way that we interact with computers, that's actually pretty narrow. And if you think about all the other ways that you might interact with computers, I think that's accessibility. And I think that's one of the reasons why I'm so excited to have worked on all these amazing different areas in my career, because you can kind of think about, like, how do you use computers in all these different ways? Like, what if somebody, can only hit one switch at a certain kind of frequency? How would you turn that into a control that would power a whole computing system? Turns out that's accessibility. I think it's really exciting. All right, one other thing. So in human-computer interaction, we've had amazing advances in how people interact with computers, and over really not that long of a period, right? So, from Engelbart's mouse and keyboards, mother of all demos in the late 60s. We have kind of the development of the graphical user interfaces. But all of these systems, I argue, kind of to make progress, have really narrowed in on a specific set of abilities. And so, Ego and O'Sullivan kind of humorously characterize this with this. This is how our smartphones see us. We have a big eye, one big finger, maybe with multi-touch we have two fingers, but we have and like little tiny ears, and all the other things that we can do really are invisible to our smartphones. So we've kind of narrowed in on this specific part of abilities. And amazingly, we actually keep doing this. Every time we come up with a new way of interacting with computers, it seems like the tendency is, well, we gotta kind of narrow in so that we can kind of fulfill like the way that people want to interact. And so here's a video of that kind of demonstrates this to me, which I think you won't in the room be able to hear the audio. We tried really hard. We did a bunch of things, but I'll describe it after I play. I think maybe on Zoom you'll be able to hear it. Not 100% sure. All right, so that was Steve Jobs at the introduction of the iPhone, and he says something like, we're going to interact with the iPhone in a way that something that we all were born with. We're born with 10 of them, our fingers. And to me, like, this was amazing. It changed how everyone interacts with phones in a variety of different ways. But it also had this assumption that people could touch a touch screen, right? And so immediately I started thinking, and actually people started thinking about, well, how can you change that interaction so it better supports people who maybe can't touch a touch screen, and certainly maybe not with the dexterity needed to use multiple fingers to do multiple things like that. All right, so I have said this is sort of the HCI's original sin. To make progress, we've narrowed the abilities, and so accessibility, one goal of accessibility is to expand those back out. All right, so here's my take on, that's kind of the why accessibility, quick rundown of 20 years of trying to motivate people to think about, why is this interesting, why is it hard, why should we work on this? For grand challenges, I tried to come up with a set of hard problems where in accessibility they've also had these really interesting set of constraints. So a hard problem to me is something that it's a known problem. We kind of know what the problem is, but it's gone years without a solution. And interestingly, especially for the current moment, most problems in AI can be mapped to accessibility. So if you think about AI, what's the goal of it is to build machines that can perceive and understand and kind of think, with quotes. What do you need to support that wide range of abilities? You need technologies that can perceive, that can kind of understand, maybe think a little bit to convert one modality into another, one set of input or outputs into another set of inputs or outputs that are supported. What I like about accessibility is that there actually are interesting constraints around all of this, right? So there's this push to actually develop solutions to real problems, right? So people really need to be able to use technology. They really want to have access to information about the world or other things around them. And so it's not kind of an abstraction. It's not kind of like, oh, wow, cool, this is a neat thing I was able to do. It's like, does this actually solve a real problem? And one of the interesting consequences of that also is that there are these utility trade-offs that I think have been fascinating. Gets to the early adopter part of the argument. Now, many of us use speech to interact with computing in various kinds of ways, but the people that I have known who have used speech technology the longest are people who are otherwise unable to type. So if you're unable to type, you might put up with a speech recognition system of, say, 15, 20, 25 years ago that had more errors because it's a way for you to enter text. All right, and again, just a caveat, these are my grand challenges. You should add your own. And I think that accessibility is filled with grand challenges. In some ways, it's, most of the things that we want to do in AI and everything else can be mapped into accessibility, so there's a huge number of them. All right, so number one, grand challenge. All right, all user interfaces are accessible. That's my number one grand challenge. And why is this hard? Well, one is that every graphical user interface platform that has ever existed has been mostly inaccessible. And this goes way back, right? So when we first got some of the more popular adopted graphical user interfaces, like Windows, this is I think Windows 3.1 or something like this, there was really no way to access. You think about like, oh wow, these are semantic things. Even if you haven't used Windows 3.1, maybe that's, those are icons. There's these windows that semantically group them. You can kind of move these things around. But from the point of view of a program running on Windows 3.1, these are all just pixels, right? At the time that they are rendered onto the screen, they're just pixels. And you wonder why a screen reader, that's the technology that a person who is blind would use, is called a screen reader, is that it literally was built to read the screen, or often more precisely, built to read commands to the graphics card to be able to start interpreting, oh, these pixels are being drawn. Can we intercept the commands that are drawn in a way to uncover some of those semantics? Like that thing is an icon, or this is the thing that's being drawn. Amazingly, around the time of Windows 95, that's the first time we've started to see API access, that you could, as a developer, actually label your graphical user interface components in a way that the semantics could be more easily computationally accessed. So instead of having to kind of guess based on graphic commands or pixels that that's an icon, you could actually label, hey, this is an icon, here's its name, here's its role. And so around the time of 1995 with Windows 95, that is when this started to be available. But it didn't solve the problem because you still needed a developer to take a lot of care and have a lot of knowledge to be able to actually put those semantics into how they wrote their code for their user interface so that it would be available later to the accessible tools. And now, like, every platform has some version of this, and they've kind of continued to get better. We have user interface toolkits that capture a lot of these things, do a lot of the work for you. But it is still the case that most user interfaces aren't made accessible. And what I think is really interesting, again, this 20-year perspective, is that in 2004, Jonathan Lazar did this study on web accessibility in particular about why web developers didn't always create accessible versions of their web page. And the kind of summary quote is, most webmasters supported web accessibility, but cited roadblocks such as lack of time, training, managerial, and client support, inadequate software tools, and confusing accessibility guidelines. Just as a side note, around this time is when I started working with colleagues to try to say, okay, we're not going to rely on the developers. We're going to let people, kind of third parties, come in and otherwise annotate these user interfaces so that even if the developer didn't do it, then they'd still be available. All right, but almost 20 years later, 6 years ago, 2020, a different set of researchers did a similar kind of study and said, developers, why are they not making accessible web pages now? Developers received inadequate formal education about accessibility, and software development cycles did not accommodate accessibility implementation. So almost exactly the same kind of response. And this is after 20 years. If you've paid attention to this industry, all of the big tech companies over that 20-year period now have big accessibility teams. There are incredible numbers of standard documents. There's also like resources to learn about all of these things. But it turns out that it's both hard and not prioritized, and so it's really frustrating to see kind of over 20 years. That's something that has actually not changed. To me, though, I got really excited, right, because suddenly we had this new way that people were producing user interface code and code in general, which is all of the codecs, the coding models that were that people were using to vibe code their way to user interfaces. And you might think, oh, that's not good because they'll still not know about accessibility. But I thought this is a new kind of way in, because if the coding models, if they produce accessible user interface code, then the developer maybe they don't have to know about accessibility. But let me show you an example of, okay, so I've got a little web page here with a really basic template. And maybe I want to add an image. So my favorite image from the golden age of internet memes is this little pig wearing red boots. And so I want to add this image to my web page. And I ask, I think this is Copilot, but it doesn't really matter. I think it's Copilot. I'm going to ask Copilot to do this for me. Image pointing to that image. All right, it's thinking a little bit. All right, so it makes an image. It just correctly points to the right image. And then it gives an alt text, which is supposed to be a description of this image, but it just provides the word image. And that does not obviously convey the amazing cuteness of this little pig and these boots. And also the thing that is super frustrating to me is that this is a long-standing challenge. In that version, that image as the alt text, this is classic, bad accessibility because it doesn't describe the image. I wrote a paper in 2007 that showed that you could actually pretty easily with machine learning build a classifier that could tell you if the alt text was good or not. Back in 2007, we were nowhere near being able to write good alt text with AI, but at least you could tell if the alt text was good or not. Anyway, so that was kind of disappointing. But what's more kind of interesting is that the codex models, maybe they don't do it by themselves without you kind of expressing it, but they do have knowledge of it. So if you say in the prompt, make this accessible, then they'll do a much better job. And so we did a study. My student Pia did this study of what these things are doing, and you have to prompt for accessibility, which is kind of sad because the whole point was, oh, these developers don't know to do it, they don't think about it doing it, they don't prioritize doing it. So we'll even know to prompt it, but you can prompt for accessibility, and they do a much better job. A lot of times, though, they give you template code that you then need to complete. So like for alt text, they might say like, insert alt text here. And so it would be kind of disappointing if all the alt text that are on the web started to be, insert alt text here. But it knows there's a problem. And a more subtle one is that the codex models will often perpetuate existing errors. So a really good example of this is imagine you have like 10 buttons on a web page, and those buttons all have like super low contrast text, right? You have like, gray on gray. Like classic, for whatever reason, there was a period in which like people thought the pinnacle of design was to put like super low contrast gray, tiny text on another gray background. If you had 10 buttons and you said, make me a new button, then the codex model is just going to make you another button with the same problem. So this repeats kind of, you can generalize that to a lot of different kinds of problems. Okay, and so you need to avoid perpetuating errors. Turns out that you can actually solve these problems. So Pia built a Copilot extension that kind of changes how some of these things work. You build in an accessibility prompt. So you say, hey, make this accessible. You display reminders for those templates. So she added in like little visual reminders that would more or less show them as errors until you fix them. And then build in an accessibility checker so that these existing errors don't just kind of sit there unaddressed and have the risk of being perpetuated. What's kind of remarkable is with these 3 changes, these non-expert developers were able to produce much more accessible user interface code. So this is across a couple of different, or 4 different common accessibility problems, like color contrast, labeling form fields, link labeling, adding alt text. And that's just with changing slight tweaks to how Copilot works. So I thought that was pretty cool, and maybe there's a path forward there. The other way that people, I'm also kind of excited about machine learning perhaps impacting this idea of user interfaces remaining largely inaccessible across 20 years is they are increasingly able to interpret, machine learning is increasingly able to interpret user interfaces the way that developers assume people are going to use them, which is essentially using vision. And so one thing I think is fun is that, again, this whole, I like to brag about the accessibility community kind of being at the forefront of a lot of things. In 1994, so this is the same, I think it's actually Windows 3.0 maybe, I forget. But there was a screen reader for Windows 3.0. And actually for Mac, that's the 1989. The 94, I think, was the Windows 3.0. There was a screen reader back then, and one of the features that it had was that it would actually recognize the different user interface components from their pixels. And it was more or less an exact match back then. You'd have to say, like, these particular pixels are this particular icon, but they'd be able to associate them. It would be able to associate them. So that's outspoken. 1994 was using, pixels analysis of the screen to then be able to convey the semantics of this user interface back to a screen reader user. The generalization of this is computer vision, right? So we can go beyond just a pure exact match of pixels and start to generalize to icons, other user interface components that the system has never seen. And so we did a project on this called screen recognition probably started in 2019, where the goal was to take a screenshot, in this case a mobile iPhone screenshot, be able to detect all the buttons and other control components, and then add those back as metadata to the screen for places when developers have not done everything they could to make their user interface accessible. And in some ways, this is sort of controversial, right? Because AI was not, and is currently still not, although it's getting closer, able to do as good of a job in making their user interfaces accessible as a developer could. And so we provided this as a tool. It's actually in your iPhone. If you go to VoiceOver, it's called screen recognition, and there, that people could access if they thought maybe the user interface wasn't accessible, or they didn't think some things were working like they thought they should. But it's super controversial because you wouldn't want developers to take the lesson like, oh, I don't have to do anything now because, oh, AI can just do it. But I think given this trajectory of 20-year span, people including, this is Greg Vanderheiden, who's one of the founders of of accessibility as a field, and also the standards that many developers don't always follow, has started to realize, hey, maybe this is, and started to instead plan for what's that trajectory look like where we don't just turn over to AI today because it's not ready, but you start to build in more of a trajectory so that AI is able to make more user interfaces accessible over time. But I will say, and this is my kind of favorite pet peeve. So these problems are remarkably sticky, and this is a screenshot. This is actually Michael Bernstein's really cool paper on generative agents that randomly chose this. But anyway, PDF documents have also been a challenge to make accessible. And by make accessible, I mean kind of label the different components. This is text, this is a heading, this is a figure, this is what's in the figure, this is a table, here's the rows and columns of the table. This seems like something, and I've been told for 20 years, oh, we can just solve this. This is solvable. It's an engineering problem. Turns out it might be an engineering problem, but it's been a problem for 20 years where it is really hard to automatically, comprehensively tag PDFs. If you are submitting to ACM conferences, I am very sorry, but part of the whole TAP system that you are going through, so some people know what I'm talking about, right? This is in part oriented toward making it so PDF documents aren't the only representation of your paper and that they can actually make an accessible PDF, although a lot of that still has to be done manually, which is kind of, kind of funny. Anyway, so we've been working on this, originally, complaining about it, and then also building systems to try to solve the problem. One of the promising approaches, we had a paper just accepted to Kai that we've been looking at is combining a visual analysis of the paper from pixels with the semantics that really are there, both in if you use LaTeX or Word. There's a lot of semantics. Everyone's like, can't you just transfer the semantics? I have never been so confused by why it is impossible with the current LaTeX architecture to translate the idea that a thing is a heading into a PDF. But if you want to bash your head against something, I promise you it's way harder than you could imagine to do that for lots of reasons. LaTeX, it turns out the compiler is incredibly complicated and easily broken. And then PDF as a format is really hairy. I mean, it started out as a printer format, right? And now it's become this document format that everyone uses. Okay, anyway, that's really hard, but we've made incredible progress, and I think we're on the cusp of being able to do this finally automatically with this joint analysis of the source document and the visuals of the rendered document. But it's taken 20 years to even kind of be at that point, which is surprising. All right, so that was my take on first grand challenge. All user interfaces are accessible. I really do think there's a lot of promise in codex models, making born accessible user interfaces more likely, and automatic accessibility in the eventually of just having computing systems that can automatically recognize user interfaces and put the semantics that should be there in there. All right, related, but I always like to mention it, usable non-visual access. And what do I mean by that? So there's one thing to take a complicated user interface, label all the components and whatever else, but a challenge for non-visual, so for someone who is blind to be able to do this, is ultimately, if you think about this big graphical user interface, all these different components, the way a screen reader presents this to the user is as a big linear stream of all these components, right? And then all the functions of a screen reader allow you to kind of jump around within those, right? The most basic would be just sequentially reading out. But imagine, go to any web page that you might frequent. If you really just linearly read out everything, you'd be 15 minutes in and you're still getting through the extensive navigation bar for even a moderately complex website. So this has been hard. This is an old problem. This is a paper by Hiro Takagi and Sheiko Asakawa. They were trying to visualize the time it took, even in 2004's web to get to some of the more deeply nested content in a web page. It takes a long time. There's also this problem that, this is a paper that I wrote with Irene Lin and then Safe Savage, who's at Northeastern now. There's this interesting problem of not knowing what you don't know if you're a blind web user. Quick summary is essentially, if I go to a web page and I expect there to be something there, like I go to the classic one, right, is have you seen the XKCD comic where it's you go to the university homepage and all you want is I don't know, the phone number for the university or the link for admissions or whatever, and none of that is there, but they have the giving page, they have the I don't know, whatever they're bragging about, the new building they built or something, and so you go to the page and you can't find the thing you want, but you don't know, is it really not there? Maybe it's nested, maybe you have to listen to this 20-minute comprehensive view of the web page. Is it just inaccessible? Maybe they put some content in a place that the screen reader can't access, or is the content just not there? And so that's also still a problem and is pretty hard. And so I got excited though recently about the potential for agents to help with some of these problems. So there's a lot of different computer use agents, UI agents that people have developed. I like to say, back in 2009, I built a web agent for this exact problem using a much different set of technology, but the idea was it would observe what you're doing on a web page and at every step give you easy access to whatever it thought might be the next step that you might want to perform for that. It is actually, it's interesting that this has remained kind of a challenge. If anybody's used any of these computer use agents, it's surprising how hard automating tasks in user interfaces has remained, even though some things work pretty well. It's wild, right? And one reason we used to say back then, even though it's a kind of a complex challenge to say what is the person likely to want to do next, there's also only, whatever it is, 100 different user interface components on this. So your chance of getting it right, even if you randomly pick, is 1 out of 100, and there's a lot of signals what's the sequentially next thing, or what's semantically most related. Anyway, it's kind of fascinating that this is both easier and harder than what you might imagine. But that technology seems like it should be really useful for accessibility. And it goes back to the utility trade-off, the difference in utility for a person with a disability. So if you have this big usability problem because these complex interfaces are time-consuming and kind of confusing to use, the agents might actually help you kind of skip through that a lot faster. And we have actually started to build systems that do this. And so really we're thinking about mixed initiative agents. So right now the way that most of these systems are presented to the user is you say up front, here's exactly what I want to do, and then it goes tries to do it. Of course, this doesn't really work for a lot of real-world situations because in the real world, what you do is you say, I want to book, classic example, I don't know why everyone finds booking flights so hard, but the classic example is like booking a flight. Book a flight from Roanoke to Pittsburgh. Turns out there's no direct flight. It's very sad. But like what I want to do there, and then the real problem is once you get that first level of results back, then you start to understand, oh, there's no direct flight. I got to make a connection. Where do I want to make a connection? How do I trade off like this or that? And so you really need a mixed initiative approach to this where the computer automates or tries to automate things that truly seem like they don't involve kind of user choices. But then when there's a user choice, you want to pause for that. You want to kind of involve them. And I think that's actually the biggest challenge in general with computer use agents or just agents in general. How do you know when the system should take initiative and when the person should want to do something? Big, but a very low-hanging fruit for blind users in particular is this whole deciphering complex user interfaces, right? There's just a whole bunch of user interfaces that, turns out the option you want is 3 levels deep in a hamburger menu and you had no idea, right? And the computer use agent is able to look at the source code of the web page in particular, know that, hey, there's an option that is exactly the thing you want and direct you toward that. And that extends whether you have a disability or not. We did some studies with students at CMU, and it's funny that working together with the agent, if you construct it right, they can actually do better than either by themselves or the agent, which is kind of maybe not so surprising, but that particular part, I was like, oh yeah, that totally makes sense. Like, people make terrible user interfaces all the time. It's not clear, like, to click on this hamburger menus. Like, you might as well declare defeat if you've used a hamburger menu. Okay, and here's an example of, something as simple as buy me the cheapest sparkling water. Well, there's flavors, there's sizes, there's all this different stuff. And so this agent that we built called Murray actually predicts when it should pause. And we did a study with blind web users, and turns out it works reasonably well. I think there's a lot of things to figure out about deploying this in a real situation, but it works pretty well, and it sets up this problem of predicting choices. All right, so usable non-visual access. I am really excited here. I think we have some ways to go, but agency preserving user interface agents, I think, are pretty exciting. Something has changed over the 20 years of working on this. All right, speaking of agency, I think it's one of the biggest challenges, and disability has a particular point of view on this. And let me illustrate that. So this is my PhD advisor. He's Richard Ladner at the University of Washington. And he always used to, I first started working in accessibility, and everyone would call the technology in accessibility assistive technologies. And he would never do that. He'd always say access technology. And I was like, why do you call it, what are you doing? And I didn't really understand why he used to always do that. And it turns out the reason he does this is related to agency. Who is in control of what happens with the technology? And a lot of what we build is access technology. It's making sure that something that was not available to someone is available, but for them to do it. The best example I have of this is a project I did not work on, but actually is a Virginia Tech project. I wonder if you've heard about it. It is the Blind Driver Challenge. Anybody heard of the Blind Driver Challenge out of Virginia Tech? One person. Okay. Good, Doug. I'm great. Oh, and I realized this is another video, so I'm just going to tell you what's happening, but it's okay. This is going to be Mark Riccobono, who is now the president of the National Federation of the Blind, and he's going to get in this car, and he's going to drive this car. And this is the most important screen here. It's going to pause on it, which is these days you might be thinking, oh, a blind driver. Well, that's going to be that's just going to be a self-driving car, right? No. Mark has there's a bunch of sensors on the car like you'd have with a self-driving car, but then there's these gloves, which convey information about what the sensors are observing. And then he's got audio that's also being, I don't know exactly how it works. But the point is, Mark is the one turning the wheel and pushing the gas and pushing the brake. And he's blind. And so it is a blind person driving a car. And that, to me, is the best illustration of access, working toward access where the blind person can drive a car versus an assistive, which would be like the self-driving car, which kind of drives you where you want to go. It doesn't mean that the only goal is access. I drove, I got to ride in a Waymo. It's amazing, right? Like, I don't want to drive most of the time. But that's kind of where you see that differentiation. It comes up a lot in accessibility. One project we worked on is in augmentative alternative communication. So this is for people who can otherwise not speak. Use a board. There's a bunch of varieties of these different boards. But the idea is in some way you enter the text that you want to speak, and then the system will vocalize that with like a text-to-speech system. This is led by Stephanie Valencia, who is at the University of Maryland, assistant professor now. So Stephanie's big insight was that most people had kind of looked at this as an efficiency problem, where it's like, it is slow to type, especially if you're kind of using, this person's using, I think it's either an eye tracker or head tracker, and they're selecting characters. It's pretty slow to type. And so most people would say, we got to make this faster. We got to make this more efficient, which makes sense, and that would be great. But Stephanie had this kind of thought that it's not just efficiency, it's also the effects on the person's agency, their communicative agency, that might be what's really at play here. And so she did these first a series of studies with AAC users, a close conversational partner, usually either a parent or a caregiver, and then herself, to kind of understand, like, what are the dynamics of a conversation, especially a conversation, and it was really important to go beyond two people. So we had these triads where there's more what are called conversational constraints, right? Where, if you are in a triad, or if you're in a group, you don't usually, it feels awkward to wait for someone to speak or know if that person is going to speak. If it's just back and forth, you say something, they say something. Anyway, long story short, looking at some of these conversational constraints in this kind of setting, she was able to find these different ways that the close conversational partner was able to increase agency. So sometimes they'd ask for permission from the AAC user if it was okay for them to kind of provide an answer. They would ask for clarification sometimes. Sometimes they would translate nonverbal cues. So also a limitation of how people had thought about this was, the AAC device is the only the path for communication. But clearly, like, people do all kinds of stuff. I'm waving my arms crazy, and and so people are doing all kinds of things to get past some of these efficiency. So they might be nodding their head, they might be kind of looking in a certain way. But things that reduced agency are when the close conversational partner would guess or anticipate beyond what they had confirmed with the AAC user, or sometimes they would share too much information. I mean, this is probably a particular problem of like parents. But they'd share more information in response to a question or different information than the user might want. And so Stephanie built a few different prototypes that kind of forefronted this idea of agency. So one is a really quick way, this was co-designed with a few AAC users, of just letting the person know, hey, I'm typing. This is a really simple arm, just to go back and forth, to kind of like a, just, hey, I'm typing. And then in the digital, and that's a physical thing, you can actually attach to the in the physical world. In the digital world, you can actually do even more interesting things. You start to manipulate how conversations are presented and developed. And so in a kind of modified Zoom kind of setting, we're able to attach what the user responds to the place where that it's most relevant. And so this helps with this relevancy problem of, if it takes you, say, 30 seconds to respond and people have continued on with the conversation, then the thing you ultimately say can feel, oh, that's really weird, what are they talking about? But if you can place it in the right thread, essentially, that's constructed here automatically, you can help kind of solve that relevancy problem. Anyway, so lots of cool stuff there. And I think it relates to all of us. This is a cartoon from I think the New Yorker or something. And it came out 3 years ago, right as everyone was trying to figure out what to do with ChatGPT, and it's, can I use ChatGPT for the tedious parts of my job? And I was like, I wish I knew what the tedious parts of my job are, right? And that goes back to this whole agency part. Like, which parts of our life, our work, would we actually want to outsource to ChatGPT versus not? And I think it goes back to agency. One thing that we worked on recently, this is a paper from WIS last year, is we tried to figure out, like, could we build a system that would ask you just enough questions to be able to properly represent you in a setting that might matter, like a response to an email. And this is different than, say, prompting, ChatGPT, because if you did that, you get the email and you say, write back this, and this, and it will often kind of add things that you may or may not want. And maybe you can go back and refine, but we're trying to think, if you're on the go, if you're trying to do hands-free, or eventually maybe someone with a cognitive impairment, we're kind of breaking these things down into particular question answers, could be beneficial. Can you distill it down to just what do you need to know to properly represent fully what the person wanted? So the system, a lot of details behind the system. But one thing one main result here is, we had these different scales of things, including ownership and agency. And of course, we thought, we compared the 3 conditions, ChatGPT, just prompting the system. We were able to outdo that by a significant amount. The thing that I thought was interesting is that dictation, which you'd think would be like fully representing people's agency, was scored also lower than our system. And that was because of this kind of interesting quirk. Anybody who's dictated something knows that those systems don't actually do what you want either. They attempt to just transcribe exactly what you write, but because there's errors and they don't match, like, oh, that's not what you get this email and it's just like this one line of like unformatted nonsense and errors and you're stammering. It doesn't represent what you wanted to say either. So that was the most surprising. I know it's like just like this little thing, but I thought the dictation tool would be the winner, and then maybe our thing next, and then ChatGPT would be the worst. But turns out dictation people don't feel, because it's not just like, it might do actually what you said to do, but it doesn't do what you wanted it to do, which is kind of an interesting distinction. All right. I said, my thoughts on agency. Let's see, all images described. So going back to my pig in boots, this is the first project that I worked on as a graduate student in accessibility, so that's why it's 20 years, assets 2006. Very different time. This is the homepage of the University of Michigan Computer Science Department. If you took out all of the images, these little blanks here, these are all the email addresses of the professors. So you literally couldn't email any professors because they didn't have, they were all in images and they didn't have alt text. Now, obviously, things have changed. So the thing I didn't show you in the last example of my pig in boots is, if you ask ChatGPT to describe this image, this is a very popular image. It's all over the internet. Also, ChatGPT is just very good at describing visual stuff. So it does a pretty darn good job of describing the adorable little pig with its boots standing in the mud puddles with the leaves and everything. So in some ways, like, wow, we've solved it, right? Maybe, but this is a great example of like that level deeper, right? So a lot of things that we visually describe, there's a million different ways to visually describe something. And so they depend, though, on context, right? So like, what is happening in this image and what does it mean? People are just super hard to describe, right? And one of the reasons they're hard to describe is because from pixels, you actually don't know a lot about a person. So we did a couple of research projects looking at identity characteristics and how people would want identity to be represented, which you can't know from pixels. But at the same time, and I think accessibility is this really complex lens on things sometimes. It's like we would hear from people who were blind who would say things like, I know you can't know a person's gender identity from just pixels, but all of the sighted people walk down the street and make guesses. And why can't I have a guess at it? And it's very complicated, but that's why it's a problem that's that level deeper. Lots of problems with visualizations. They're just starting to get better. but we turn data into visualizations to help people better understand. Even if we technically make it this accessible, which during the COVID, people were always passing around these COVID charts back in the day, and almost none of them were accessible. Even if we were able to make this technically accessible, what does it mean to make a visualization accessible? If I just give you all the data points, is that accessible? You can't see the trends as easily as you could as a visualization, et cetera. So a lot of progress here because these systems are way better than they were, but a lot more to do. And descriptions are hard. All right, visual access to the world. I think 20 years ago, it was so far off that we'd be able to do something like describe that pig in boots with a system, or let alone like ask a question about an image. One of the more well-known projects that I worked on in this is 2010 was this crowdsourcing system where a person who was blind could take a picture, they'd ask a question about it, and then people on the internet would be recruited pretty quickly to answer those questions. But now we have Be My AI, which is kind of doing a very similar thing, but all with AI. They have a partnership with OpenAI. And so this is all solved, but then you start to think, what's that level deeper, right? It's not just asking questions. There's all kinds of things. Like a lot of people, this is Cheiko Asakawa again, but she's working on how do you guide people through unfamiliar spaces, so like airports and bus terminals or around campus. If you're just asking a question every 5 seconds, that's not an effective way probably to get through navigation tasks. My former student, Hanon Guo, has a series of projects, but this is one from WISC a couple years ago called WorldScribe, where the idea is, can we actually bring contextually relevant information? So the other thing is, if I'm out in the world, if I took a picture of this room, again, thinking about like all the visual descriptions you could make, well, what's the one that I want? And when do I want it? And so he's building systems that can, for instance, you say, hey, I'm looking for the 67 bus, and then it doesn't say anything until the 67 bus comes, right? It's different than asking just a single shot question. And you can imagine generalizations of this, like maybe I don't have to say the bus number, or maybe it's not just the bus, or hey, there's something interesting happening here, or something we've wanted to do for 20 years, which you still can't do, is a blind person walks the same route to work every day, and some point there's a new coffee shop. How would you know about it, right? Well, if you had a system, maybe smart glasses or whatever else, that was always observing and comparing those routes. But you can't just compare naively, because then you get like, hey, there's a new car parked here, new car parked here, new car parked here, there's leaves on the trees there weren't before, like all that sort of stuff. So how do you do that smartly? Lots of like really diving into deeper tasks. So this is a student from CMU, Franklin, who's working on just kind of understanding things like cooking scenarios, like what kind of visual support would you actually need. This is Amy Pavel, who's at Berkeley now, used to be a postdoc with me. She's working on kind of visual support in those kinds of situations. How do you actually help somebody with their cooking tasks, et cetera? So visual access to the world has improved a lot. There's still just an incredible amount to do. And part of that's, the world is dynamic, contextual, and situated. And people in AI generally are really excited about this with like world models and everything. This is another place where I think accessibility is a great lens to look through that. If you're really going to build a world model, it should be able to do those things, right? It should be able to help you with navigation and all the random tasks that you're doing, and like knowing what contextual, like based on context and timing and what you've seen before, what information is important for you. All right, I'm running out of time. Somehow I got through this before, but you know what? I'm going to go, I'm not going to go quickly. I'm going to give a gist of some slides. So one thing I really like about captioning is that people who use captioning very correctly would fight back against anyone suggesting that we use automated captioning. And now they're like, wow, it's actually getting better. I don't want to get rid of my human captionist for important things like legal or hospitals or other things like this, but it actually is getting good enough that they'll use it for different things like impromptu meetings or other things where a human captionist is not going to work. But there's still this, what I love about all these problems is like there's that next level. So at Apple, we've worked a lot in atypical speech. So how do you support speech recognition for people who speak in a different way because of a disability? Also, the kind of analogous parallel, people with accents, but we've really looked at people who stutter, people with dysarthria, things like this. there's a lot more question about like, how do you design captions? So it's almost like the same analogy of the visual world. You don't just want to describe everything. It's like somehow you have to structure the caption so people can, especially someone like me is like getting toward the end of my talk, speaking even faster than I was before. And how do you structure that information so someone can keep up, because it's hard. And then there's a whole set of new things like sign language recognition and generation. This is a colleague of mine, Apple Colin, who has been working on some of this stuff. It seems like actually there's a much better chance than before where you could actually represent some of the richness of sign language, which is more than just hand shapes. It's hand shapes, placement, lots of things happening with the face, with grammar and things like that. Let's see. I'm going to skip. OK, universal captioning. I think supporting diverse speech, including sign languages, different ways of speaking, still a big problem. And then the last one I'll go over is availability, just because I think it's an interesting, somewhat subtle one. So this is in accessibility, the idea that there is a solution that exists, but it is, for whatever reason, not able to be used by you. And I first started working on this in graduate school, where at the time, there was this whole like move of a lot of what we did on our computers from applications that were installed on like your computer to the web. I know it's kind of weird to think about like that was a model, but things were like your email program was like a program on your computer. So like if you weren't at your office or your home, you weren't accessing that that email. Then around this time, people were releasing Gmail was like a few years old now, but at that point, but you could access it on the web. So any computer you had access to, you could access your same Gmail, or like Google Docs was coming out around this time, right? So like you could actually have all your documents on whatever computer, and smartphones weren't quite there yet. So like the idea that you'd have a computer at the library, a kiosk, whatever, this was really important. But for a person with a disability who used particular technology to access their computer, they didn't have that available to them. And so at the time, what I built as a graduate student was a system that would let a person go up to any computer and build the assistive technology into the web, so that you'd have a screen reader that you could pull up on the web. This video is not playing, but we don't have time for it anyway. But my colleague, Sang-Yin Han, who was blind, he went to this computer. This was the UW library back then. Pulled up this web page, which you can do non-visually. It's a little hard without feedback, but you hit Windows key R and type in the URL, and it just starts speaking to you. And then you can visit any other web page at the time. One big thing that has changed, and this is like remarkable progress, is that accessibility to a large degree is built in. So in this is an iPhone. There's like 50 different features. If you've not gone in there, it's actually amazing. 50 plus different ways that you can change how your device works. Maybe it speaks. Maybe it takes different kinds of input. Maybe it does all these different things. All this is built in, and it's not just iPhone. Obviously, I like the iPhone, but Android, Windows, Mac. All these things have built-in accessibility features now. But most people have no idea that these exist, and they have no idea, even if they did know, they kind of know they exist, what they would benefit from. And so we did this study. This is Jason Wu, former PhD student of mine who's now at Purdue. He did this study at a retirement community. And it's kind of hard to structure this so you don't kind of give away the answer. But he asked questions like, if you started having trouble, seeing what was on your iPhone, like what would you do? And like the vast majority of people, I don't know what you would say, but the vast majority of people didn't say, I'd go into the accessibility settings and turn up this font size. They said, I'm going to go to the eye doctor. Of course, the eye doctor doesn't actually know about these settings either. Anyway, and this gets even more less likely to know about these sorts of things if it's more and more subtle. Like my favorite thing, if you have anyone, really anyone, but anyone over like 50 or so, 60, ask them to double tap the side button on their iPhone. Double tap the side button on their iPhone. It brings up your wallet, how you pay for stuff. A lot of people don't even know you can do that, but I bet they will have problems doing this. It's actually, you have to do it pretty fast. It's kind of an awkward thing. It's like over here, people aren't used to doing that. And they will probably get it on like the third try. Turns out there's an accessibility setting where you can reduce the required latency between those taps, so you can make it more forgiving. Nobody knows about that. I've been arguing, hey, you could just, if you notice somebody, we called it a near miss in this paper. If you saw somebody do it a couple times and then they got it, that's a pretty good indication they were struggling with it. Couldn't you just turn it on? Probably reasons not to do that. But anyway, lots of stuff like this. Availability, it's in your pocket a lot of times, and you don't know it's there, and you don't use it. That's a wild availability problem. One extension, because I wanted to make this kind of relevant, one of the things I've been working on is the idea of personal agents. So agents, just like with Web Anywhere, you could bring, that was the name of the system, you had your assistive technology anywhere. Well, right now, like there's all these cool agent things happening, but they seem to be kind of constrained to running on a particular device, your particular computer or phone or whatever else. What if you had the ability to separate out the agent from the computers or computers that it controlled? And so we built this little prototype. I'm not a hardware person, that's why it looks ugly, but like built this little system that what it does is it bridges the computer where the agent is running with the devices that it controls. And it's actually really easy to do this, it turns out, because of a lot of things we covered earlier in the talk. One of them is that to capture the state of these devices, you don't need any special permissions. You can just plug them in, and there's an HDMI capture there, and that gets forwarded back to the computer, uses pixels, pixel-based understanding of the user interface. And then sending commands, you can just send keyboard and mouse commands, right? So this is just like you just register as at a HID device and send keyboard and mouse commands. And the cool part about this, which the Kai reviewers did not agree with, is as far as I know, it's the only system that you can literally, and this is what I thought was the killer demo, plug in to a Mac, have it control a Mac, plug it into an iPhone, have it control an iPhone. That's really hard actually because it's various restrictions. Plug it into an Android phone, plug it into a Windows computer, and it can just observe and control all of these. Technically, it's kind of straightforward, but also I think conceptually, there's this really interesting notion of being able to take your agent wherever you are. There's a video of this. All it is really is me plugging in multiple devices into this thing. So I'll let you, you could watch it later if you want. Anyway, as a summary, okay, so I use ChatGPT to make these turtles. And the metaphor is that we have made incredible progress on the first turtle in a lot of these grand challenges in accessibility. But even for ones where it seems like we've solved the surface level problem, there is another turtle. Pretty good at this one. There is another turtle. I hope that there's not just turtles all the way down, because I think we can pretty soon hopefully make substantial progress on accessibility. And grand challenges in accessibility have depth, and so that's the parting thought I will leave you with. Thank you.